Hello, YouTube. It's your boy Tonkus, and I'm going to be trying something a little different today. This video is going to be more along the lines of a talking head kind of thing, so feel free to listen in the background or skip ahead to the TLDR section at the end of this video if you don't want to hear what happens when I don't restrain my rambling. Anyway, alrighty, let's start this off with a quick note about the previous video. Seagate's formatting tool does, in fact, low-level format the drive, as in it wipes out absolutely everything and lays down new sectors on the disk. And yeah, it's just a little detail that was kind of bugging me when I was watching my last video. Anyway, enough about that. Let's talk about what the heck that program was even doing in the first place. Starting off though, I do need to give a little bit of context as to some terms that I'm going to be bringing up in this video. First of all being CHS. Modern hard drives use the LBA, or Logical Block Addressing System of Addressing, and we're just going to take a quick look at LBA's predecessor, CHS, which stands for Cylinder Head Sector, and it's a reference to the physical layout of a drive, as in like the actual mechanical parts. And yeah, as far as each individual term in that acronym goes, a cylinder is, a cylinder is also known as a track, first of all, and it's in reference to the individual rings of data on a hard drive's magnetic platter. I'll be using both terms interchangeably throughout the video, and each ring is then sliced up like a pizza into individual sectors on the disk, and sectors are the smallest definable chunk of data accessible directly by a hard drive, and they're usually around 512 bytes in size, so if I remember correctly, I think using certain formatting tools or options, you can change the size of a sector. And let's see, I have the C and the S, so we have the H now. So a head in CHS is the actual electromagnet in a hard drive that does the reading and writing of data. And for every disk on a hard drive, you'll usually have two heads, though some drives will only have one head for a single platter in a like stack of platters, where that single head is okay. I'm just gonna go off on a tangent for a moment because I already am on a tangent, but some disks will have one side of the disk hold like diagnostic data or special information about how the disk is working, like for example bad sectors, identification information, stuff like that. And those like special reserved sectors are automatically hidden by the drive, and that's why some drives might only show up with an odd number of heads instead of even, because that last head is on the diagnostic side of the platter. Anyway, now we can actually move on to the meat of this video. So as far as formatting goes, I'm going to be walking things through as they showed up in the previous video where I was going through the options in the Seagate formatting tool, because low-level formatting pretty much uses all these options. So first of all is the interleave. The interleave of a hard drive is referring to the way that a drive reads sectors and like what order they read them in, because drives can only read one sector at a time. Depending on the speed of the controller and its rotations per minute, or RPM, the disk might have to spin multiple times in order to read a single track's worth of sectors. So ideally, the drive only has to spin the disk once to read all that data, and that is known as a one-to-one interleave, though if the drive for some reason has to take multiple full rotations to read it, that's known as a 2-to-1 or even 3-to-1 interleave, depending on how many rotations are required. And that's usually because the controller, for whatever reason, is too slow to like catch up with the amount of data streaming in. And as a result, the data has to be offset. And let's see. Either way, this results in a pretty visible impact on the speed of the drive as well, which, if I remember correctly, the Seagate video did actually display on screen when it was showing the optimal interleaves. Because if you have to wait for the disk to spin 2 times or even 3 times to read a full track of data, you're going to have to wait longer for that disk to actually spin all the way. And now, next up, head skew. Most hard drives are only able to read from one head at a time because the signal that's being read has to go through an amplification circuit for the signal to actually become strong enough for the controller to read properly. The problem is, usually there's only maybe 1 or 2 amplifiers on the hard drive circuit board, meaning that it has to electronically switch between what head is being read at the moment or being written. And as a result, there's a little bit of a delay, even if it's fully electronic. And that's where head skewing comes in. The skew in head skew refers to how the sectors across 2 sides of a disk, and thus 2 heads, might be a little bit offset in order to give the electronics time to actually switch which head is being read from. And this way, data can be read almost instantly after switching ahead instead of having to, for example, wait for the disk to spin all the way back to where it was trying to read from before, back when it first switched ahead. For example, this. So, say that you're starting at the first sector of a disk and you're reading from the top head of a platter. As the disk is spinning, you're reading that track starting at the first sector. At maybe sector 6, you want to switch to the second head, but by the time you switch to that second head, you might already be at sector 7 or even 8. And so if you have a skew, then when you switch from the top head to the bottom head, you'll end up switching from sector 6 of the top side of the platter to sector 6 on the bottom side of the platter. And from there, you can just keep on reading like as if nothing has happened. But this also means that switching back might introduce a little bit of latency just because, since the data is skewed only in one way, the result is that switching back in the opposite direction against the skew will result in the disk needing to make a full rotation in order to get back to it. But let's see. Okay, cylinder skew. And by the way, these awkward pauses are just because I'm reading off of some notes that I wrote on my low-level formatting script, because a lot of this information is actually torn straight out of the Seagate formatting tools instruction manual, which does define all these terms. If I remember, by the time I upload this, I might provide a link if I can find it to the document. If not, then I don't know, this video serves as the source. Okay, before I get sidetracked too much, cylinder skew. So cylinder skew is pretty similar to head skewing, but instead of the electronic switching that happens between heads on a platter, this in this case, cylinder skewing is referring to switching between the actual tracks on the disk, which means that the arm inside the hard drive has to physically move. And as a result, there's even more latency that you have to account for in the skew because instead of having just a handful of maybe even nanoseconds worth of latency, you have to account for several milliseconds of latency in order for the drive head to actually move to that new location. And the process of cylinder skewing is pretty much identical to head skewing, so I'm not going to go over it again. So, yeah, those are actually the main parameters all covered already. And let's see. Yeah, this video isn't a deep dive on how drive formatting works, and if I did make a mistake somewhere, feel free to correct me down in the comments. So, yeah. Congrats, you made it to the end of the video. Yeah. TLDR section coming right up next. To recap, CHS is short for cylinders, heads, and sectors, which are the rings of data on the disk, the thing that actually does the reading and writing, and the bits of the data that the drive itself actually handles, respectively. Interleave is organizing the sectors in a way that makes the data speed go faster, pretty much. And head/cylinder skew is the process of shifting your sectors a little bit so that then when you switch between heads or tracks on a disk, you don't have to spin the disk all the way around again to reach the same data or the same point on the disk that you were trying to read from. And yeah, that's it. Okay, thanks for watching. Go away now or maybe subscribe or something. Bye!